The problem is, if cos x minus y plus cos y minus z plus cos z minus x equals to minus 3 by 2, then you have to prove that sin x plus sin y plus sin z equals to cos x plus cos y plus cos z equals to 0. So what I feel is today's question is a bit special in the sense, by looking at the problem you may be thinking that the solution is going to be very lengthy, you have to do lots of manipulations, apply many identities to arrive at the final solution. And that's partially true because it depends on your method of solving. But don't worry, in this video I will discuss a method by which we will get to the final answer in relatively very few steps. So first of all, pause the video and try out yourself and then continue to the explanation. We will start with this one. Cos x minus y plus cos y minus z plus cos z minus x equals to minus 3 by 2. Then by multiplying 2 both sides, we will get this equation. In the next step, bring minus 3 to the left hand side and write 3 plus 2 multiplied by. Then inside the square brackets, open these cos terms using the identity of cos a minus b, which is equal to cos a cos b plus sin a sin b. So by using this in place of cos x minus y, we can write cos x cos y plus sin x sin y. And similarly, in place of cos y minus z and cos z minus x, we can write the following. And this equals to 0. Now watch very attentively as the next two steps are the most important steps of this solution. So break 3 into 1 plus 1 plus 1 plus 2 multiplied by. Inside the square brackets, write all the sine terms together and all the remaining cos terms together and equals to 0. In the next step, we are going to use one of the most basic identity of trigonometry, that is sin square theta plus cos square theta equals to 1. So by using this identity, in place of the first one, we will write sin square x plus cos square x. In place of second one, we will write sin square y plus cos square y. And similarly, in place of third one, we will write sin square z plus cos square z. Then open the square brackets and write plus 2 times this sin expression plus 2 times this cos expression. And don't forget to equate it with 0. Now in this equation, segregate all the sine terms and cos terms. And then in the next step, write all the sine terms together and all the cos terms together. Okay. Now as you can see, both these long expressions of sine and cos are symmetric. And can you find any kind of pattern here? Pattern of any identity or anything else? Let me tell you, by observing the structure of these individual expressions, you will find that we can use here the identity of a plus b plus c whole square, which is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. And by taking out 2 common, here we will get this expression, whose structure is exactly identical to the structure of these ones. So by using this identity, in place of this long sine expression, we can write sin x plus sin y plus sin z whole square plus, similarly, in place of this long cos expression, we can write cos x plus cos y plus cos z whole square. And this equals to 0. Now to understand the next step more clearly, we will look at a simpler version of this equation. So for this, let us assume that sin x plus sin y plus sin z equals to a and cos x plus cos y plus cos z equals to b. Now tell me one thing, in this scenario, is there any possibility of getting the value of a and b as unreal? Well, the answer is very simple. As we know, the range of sin theta and cos theta is minus 1 to 1. That is, for any angle theta, sin theta and cos theta will always give a value in the range minus 1 to 1. And I don't think you will find any unreal number in this range. So that's why here sin and cos will be real. And as left hand sides are real, we can say a and b are also real. Now for any real number a and b, if a square plus b square equals to 0, then what will be the values of a and b? By saying this I mean, for what values of a and b, this equation will be true. One thing to note is, square of any real number is always and always non-negative. You can check this for any real number you want. That may be positive, negative, rational, irrational or 0. So that's why in this case, a square and b square will be non-negative. Now this equation is saying that by adding two non-negative values, you will get a 0. So first thing, we all know that by adding two positive numbers, we will never get a 0. That's why this is possible only and only when a and b are individually 0. So a square equals to 0 and b square equals to 0, which further implies that a equals to 0 and b equals to 0. Then by keeping the actual values of a and b, we will get sin x plus sin y plus sin z equals to 0 and cos x plus cos y plus cos z equals to 0. And in this way, we get our final answer. Now one more thing here. By observation also you can say that if this equation is true, then 0 will be an answer. But the problem here is you cannot be sure whether 0 is the only solution or any other solution is also possible. And do not think that these steps are not that important. Because if there would be any other expression, then the situation may be different. And we may not proceed in the same way as we did in our case. So that's why you should go step by step with the process in these types of situations. I hope you understood everything clearly.